Hi everyone! So in this video, I'm going to go ahead and discuss naming acids and bases. So let's go ahead and get started. So the good news is naming bases is super easy. You've already done it. So it follows ionic compound naming rules. So basically we take the name of the metal, whatever it is, and we add hydroxide. So in the case of NaOH, Na is sodium, so sodium hydroxide. CaOH2, so that is calcium hydroxide. And then remember to go the opposite way. Barium is +2, hydroxide is -1. So when you do that flip-flop and crisscross those superscripts and make them into the subscripts without the charges. So that becomes BaOH2. And remember, we put parentheses around polyatomic ions whenever we have more than one of them. So that's why we have those parentheses for that question. There's also one other base I do want you to memorize, and it doesn't follow those naming rules, and that is ammonia, NH3. So that is just one you're going to have to memorize. It's a base, but it doesn't follow that metal plus hydroxide pattern. Okay, so for acids, they're not that much more complicated, and there's a few steps that are going to help us out with that. So for the name of the acid, we're going to look at the anion name. So whatever the compound is, we're going to focus on that anion, so the negatively charged thing that comes at the end, and think about what its name is. So we're going to split the acid into its ions, so the cation and the anion. For the anion, we want to use the correct naming rule based upon the name of the anion. And then we're going to insert that stem into the naming rule. So let's go ahead and work through some examples of this. But first, the naming rules themselves. So if our anion ends in IDE, we're going to have the hydroic acid. Okay, so mnemonic to help you out with that. My ride has hydraulics. Okay, so an example of this would be chlorine. Okay, so the chloride ion would be hydrochloric acid. Anything that ends in ate, okay, for the anion, that's going to have the stem of it and then ic acid. And the mnemonic for this is I ate something icky. So an example of this, if we have the nitrate ion, then be nitric acid. And then if we end in ite, okay, so that A versus the I does make a difference, then we would have the us acid. So mnemonic to help us out with that, Sprite is delicious. Okay, so if I have nitrite instead of nitrate, nitrite would be nitrous acid. So let's go ahead and do some examples. If we look at this one, HClO4, I'm going to split it into the two different ions we have. So we have a hydrogen ion, and then we have the ClO4 minus 1. Now, ClO4 minus 1 might not be a very common one, but if you look it up, it is known as perchlorate. Okay, perchlorate. We want to focus on that 8 ending. Okay, so with the 8 ending, we're going to use rule 2. I ate something icky, so it's going to be something ic acid. So if we put it together, we're going to take that beginning part, the perchlor, add the ic, and it becomes acid. So HClO4 is perchloric acid. The next one, HF. So we're going to go ahead and split this one up into its ions. So we have hydrogen and the fluorine atom, which becomes fluoride for the ion. So ide, my ride has hydraulics. That is rule number 1. So we're going to take the fluor and insert into the hydroic acid. So HF is hydrofluoric acid. Okay, the next one, H3PO4. So this one we actually have 3 hydrogen ions, but we just have the 1 phosphate. So think I ate something icky. So I'm going to take the phos, and then I'm going to add ic. But this is one of those weird exceptions. Anytime we have the phos in acid naming, we add an or, okay? Because otherwise we'd have phosphoric acid, which just kind of sounds weird. But what it actually ends up being is phosphoric acid. Okay, and that's probably one you've heard before. It's oftentimes a little bit added into pop to give it kind of that sour taste. So phosphoric acid. So let's try another one like this. This is H3PO3, not 4. So again, we're going to split it up into its ions, 3 hydrogen and the PO3 minus 3. Well, this is phosphite. So we're going to use the ite, so Sprite is delicious. So I'm going to have the us ending, okay? But I still need to add that OR. So that makes a little bit more sense of pronouncing. So this one becomes phosphorus acid. And it's only really with anything that has the phos beginning, so phosphate, phosphite, that you need to add that OR. Okay, so something else you might need to do is to write the formulas. So for this, we're kind of deconstructing. We want to figure out which rule was used. So is it Sprite is delicious, my ride has hydraulics, or I ate something icky? That's going to help us figure out the anion. And then from there, we're going to match it up with hydrogen ions to fill out the chemical formula. So if we look at nitric acid, well, ick. I ate something icky. So we're going to have nit plus 8, so nitrate, okay? So that gives us NO3 minus 1. And since we're minus 1, that means we're going to need 1 hydrogen to balance that out. So HNO3 is nitric acid. The next one, acetic acid. Okay, I have the ick again, so I ate something icky, so this is going to be acetate. Okay, CH3COO minus 1. So we're going to need to add 1 hydrogen. So this one, it can be written a couple of different ways. Sometimes you see the H at the end. Sometimes we kind of group them together a little bit more. But HCH3COO is acetic acid. And again, that can be written a few different ways. So this is actually what's in vinegar. Okay, and then hydrobromic acid. Well, we have the hydro and ick. So my ride has hydraulics. Okay. So I know that my anion must end in ide. So I'm going to take that brom in the middle. So I have bromide is Br minus 1. Now I need to balance it out with hydrogens. So HBr is hydrobromic acid. The next one, sulfurous acid, us. Okay, so Sprite is delicious. That is rule number 3. In this case, we know the anion must end in ite. That means I have sulfite, because I take that stem, I add the ite. So SO3 minus 2. Now this time I have minus 2, so I'm going to need to add 2 hydrogen ions to balance it out. So H2SO3 is sulfurous acid. So I hope that helps. If you have any questions either with writing the name or the formula for acids and bases, please let me know. Otherwise, have a good day, everyone, and I will see you later. Bye.